Hello and welcome to the presentation of the paper called Indentation in Source Code, a randomized control trial on the readability of control flows in Java code with large effects. This is a joint work with Johannes Morzeck, Werger and Volker Gruhn, and my name is Stefan Hanenberg. The paper was published or is currently published at the 18th International Conference on Software Technologies, ICSOFT 23. So let's start with a quick overview and the results of the current study. What we did was we performed a randomized control trial on indentations where participants were given source code. We had 20 participants, which were 10 students and 10 professional developers. The task each participant had to do was to respond to the question, what does the code print out? And the code had 49 lines of code. And the measurements that we did were solution time, so the time until a correct answer was given to us. The main result of the study was that indentation had a strong and a large effect. Strong means we had a p-value of 0.001, and large means that we had a partial eta square of 0.832. And spoken in terms of ratios, it means that on average, non-intended code required 179% more time than intended code. So participants were much slower answering the question correctly on non-intended code. So the interpretation is indentation has a strong and large effect, and of course this means source code should be indented. Before going on with the presentation, we want to say something very unusual. We would like to thank the program committee of ICSOFT for accepting the paper. Actually, we are aware that indentation is no bleeding edge technology, so it's rather old and boring. All developers indent code. We tell students to indent the code, and the question is, in general, why should program committee accept such a paper? But what we would like to emphasize is just because the technology is old, that shouldn't stop us from studying it. In case it turns out that a certain technology or a certain technique is not being studied that well or that often. Let's motivate this work. Our belief is that technology should be evaluated before it is being applied or it is being taught. So we think technology shouldn't just be invented and provided on the software market, but we think that especially science should provide evidence when or when not such technology is working. And we think that this should happen even before tools are being developed. So before companies spend too much effort, or even PhD students spend too much effort in a certain technology, they should check whether such technology has the potential to have any positive effect. In teaching, we think that students should learn and apply technology. This is what we're currently doing, but they should also learn why a technology is being taught and applied. So we think that while teaching a certain technology, we also should give students the arguments why a certain technology should play a certain role or why something should be used. And we think the role of the scientific literature is that this literature should give the evidence on the effects of a certain technology. So we currently speak about indentation. So this is the focus of the current presentation, and we know every one of us knows what indentation is. These are simple formatting styles that we use in programming, and they are taught from the very first moment in programming. So in the first lecture, maybe in the second lecture in programming, you already tell your students that they should indent their code. And we find much tool support for indentation in IDEs and for programming languages. So let me say something briefly about indentation. On the left-hand side, we see indented code. On the right-hand side, we see non-indented code. The code is relatively trivial. So it does just print out an argument that is being given to a program. And in that case, it's Java source code. And in case no argument is given, the program just prints no args. So what is the role of indentation? Well, indentation highlights certain code fragments by adding additional space, typically before a certain statement is found in the code. And indentation is used for different language constructs. So in this case already you see that indentation is being used to highlight class bodies or method bodies or if statements or loops. And as I already said, developers are told or they even feel the urge to indent the code. And this already right from the beginning of their career. And especially in universities, you very early tell your students that they should indent their code. So taking into account that indentation is a very old technique, there is a need to speak about the work that we already find in the literature on indentation. So what we found is altogether 12 experiments between 1974 and 2019. And altogether, these 12 experiments are distributed over 9 publications. And what you see here in the table is for each experiment, whether or not an effect was determined. And for each experiment, additionally, whether an effect size has been reported. So let's first give a summary. So we currently speak about 12 experiments with indentations as controlled factors that we found in the literature. And if we go through the list, only 4 of them measured an effect. And for one of those experiments, we have to say that it was replicated by other authors and the results were different. And the other authors, which is in that case Bauer et al. In 2019, their interpretation was that the replication of the other experiment was not successful and it just showed different results, and their interpretation was that they didn't find an effect of indentation. And if we just concentrate that the question is not only whether an effect has been determined, but also what the size of the effect is. In fact, only one experiment remains, and it's an experiment from 2010 by Albayrak and Davenport. And it's for us not essential what exactly they did. In fact, it's very hard to find out what exactly they did because it's a quite rough description of the experiment. The only thing or the essential thing for us is, in fact, we just found one experiment in the literature that found a positive effect of indentation and that reported an effect size. But if we take a closer look into it, we find that the effect wasn't that extraordinarily large. So in the experiment, participants had to find bugs or defects in code. And with indentation, they found 25% fewer functional defects. But as I said, many details of the study are unclear, or at least they are not described in the corresponding paper. So our conclusion on it is, although we use indentation frequently and although we teach indentation to first-year students, there's not much evidence in the literature that shows that indentation has a positive effect. And from our perspective, this means that this has to be fixed. So in case indentation has an effect, this must be it must be found in the literature. And this is something that we need to give our students in order to argue why indentation matters. So before thinking about how an experiment should look like, there is a need for preliminary considerations. So we have to think about what do we think influences the potential effect of indentation. So let's start with a very trivial example. So it's just a hello world example where hello world is printed out in something else. And what we find here in the example is this is non-indented code. But do we think that indentation plays for this example a major role? And we personally think no, it does not. So the semantics of the code is probably easy to understand just because you can read the code from top to bottom. So if you take a look into the main method, you can read the first line, then the second line, and then the third line. And this is what you have to do. And since after this method do something else, nothing else occurs, there's probably no need to understand how the indentation levels actually are. So we think in this code indentation doesn't matter. But we also have to think about when we think when does indentation matter, we have to think about what should we ask people about code. So let's use the example again. So what about asking someone about how many lines of code does the code have? Probably indentation doesn't play any role here because you just have to count the lines, and there's no reason why indentation should have any effect here. If you ask how many methods does the class have, indentation probably also doesn't play a role because the new lines here in this code are probably enough to highlight the different methods in the code. So this preliminary consideration tells us that indentation is not for arbitrary questions or for answering arbitrary questions on the code, but indentation probably plays a certain role for certain kinds of code. So let's concentrate a little bit more on where we think indentation plays a role. And let's take a look at this example. What happens in this example, it's a program which takes two parameters, and depending on the value of the parameters, you have to go to different then or else branches. If we take a closer look into it, we think if you start this program with the parameters 5 and 20, indentation probably doesn't help much. The reason is for the parameters 5 and 20, you can read the program from top to bottom, and you stop with at the line where print 5 is being executed. And this situation is different if the program is started with the parameters 11, 11, because in such a situation, you have to jump through the code. So when the first if statement occurs, which checks whether both parameters are not equal, you have to jump into the else branch. And we believe that indentation helps you to jump into the else branch because we think it might make it easier for you because it gives you a visual representation where the else branch occurs. The other thing that we might think about is what the role of the brackets are. So we think that brackets potentially play a role. So if brackets are available, probably it helps you to navigate easier to the then or else branches. So let's summarize our preliminary considerations. So we think indentation has an effect if there are different branches in the control flow in our program, and we think the effect of indentation is larger the more code can be skipped. So the more code you can jump over, because we think that indentation helps you to identify the different branches. And we also think that brackets might have an effect, and it might reduce the effect of indentation. So in the presence of brackets, probably it's easier to identify which parts of the code belong to what then or else branch. So based on these preliminary considerations, let's define the experiment. What we did was we had two different dependent variables. The first thing is the time until a correct answer was given, and the second dependent variable is the subjective rating. And for subjective rating, we used the NASA TLX, which is a standard questionnaire. The independent variables, which we all measured as within subject variables, were indentation with the treatments indented and not indented code. The second variable were whether or not brackets were available, and we defined three different kinds of skipping. So non-skippable code means that hardly things can be skipped inside the code, so you can relatively easy jump to different places. Skippable code means that there are larger chunks that you can skip while reading, and mixed code is something in between. The non-controlled variables were the background, where we used students and professionals as participants, and the task ordering was just random. So as we said, all independent variables were within subject variables, and they were just randomly ordered. And we had fixed variables, and one of the fixed variables were we had 48 lines of code for each code snippet, 48 lines of code without brackets. So with brackets, the number of lines of code was slightly more. So as already said, we have now 12 treatment combinations, so all independent variables multiplied, or all treatments of independent variables multiplied with each other. And to get an idea how the code looks like that we gave to participants, there were just if statements within if statements. There were additional if statements, or after an if statement there could be another if statement. And as we already said, we distinguish between skippable, non-skippable, and mixed code. And skippable means that the outer if statement already can be skipped, so the then branch of the outer if statement can be skipped. For non-skippable, it means that this is not the case, but inside the outer statement some code can be skipped. And mixed means something in between, so you have to read some outer statements and you can skip some outer statements. So let's take a look into the results from the dependent variable, which were the time measurements. So what you see here on the left hand side is the interaction diagram of the variables skipping and indentation. So what you find here is, first of all, there's a huge difference between intended and non-intended code, but this difference depends on whether or not the code can be skipped. So for non-skippable code, the difference between indented and non-intended code is not that much, so it's just factor 2. And as soon as we have mixed or skippable code, this factor is higher, which is approximately factor 3. So the other thing is the variable background. So whether or not students or professionals have been tested had no effect. As said, indentation had a strong and a large effect. So non-intended code took about 179% more time on average. And we had this weak interaction effect between the variables indentation and skipping. What's slightly more interesting is brackets decreased the indentation effect in skippable code, which is not visualized here. In case you're more interested in that, take a look into the numbers within the paper. So let's take a look into the results of subjective ratings. What you find here is a table which summarizes the statistical analysis. And what you find is no matter what category of the NASA TLX we use, we always find that the subjective perception of participants was comparable to our time measurements with respect to indentation. So in all cases, you always have an effect of indentation, and it's always a positive effect. What's also interesting is, with respect to brackets, you find something comparable. And it's interesting because in our experiment, we didn't have brackets as a significant factor. So it means that participants perceived an effect that was not contained in the time measurements. And from our perspective, it means that we should be slightly careful with subjective ratings in general. Let's summarize and conclude the current presentation. First of all, we focused on indentation. Indentation plays an essential role in education and practice. However, indentation is hardly studied. In fact, between 1974 and 2019, we only found one single experiment that found a positive effect of indentation and that measured the effect size. And there were a bunch of experiments that didn't measure any effect at all. So it means that the scientific literature can hardly be used to argue for the need of indentation. And especially, we cannot just tell our students to say, take a look into the literature and there you'll find why you have to indent your code. So in order to solve this problem, we run an experiment on our own. It had 4 factors: indentation, skipping, brackets, and background. Indentation was our main factor, and indentation revealed a strong and large effect. And with respect to brackets, it turned out that participants perceived a bracket effect, but we were not able to measure this effect in terms of time measurements. So in order to conclude the presentation, we think it's a first replicable controlled experiment on indentation that revealed a large effect. And in fact, we already did a replication of that, although there's no publication available yet, so it's under review. So this experiment can be used to explain to someone why code should be indented, because we can just tell now someone, yes, because it takes much longer for you to read non-indented code. And our first ideas of using skippable and non-skippable code could be used to work on a more formal model to predict the effect of indentation. In fact, this is something that we already did, or that we already have a paper on, but this paper is currently under review. So thank you very much for listening to this presentation. In case you have any question concerning whatever, just drop us an email or write a comment to the presentation.